Welcome back, everyone. Today, we're diving into a decryptage, a real breakdown of something absolutely fascinating and, honestly, totally vital for the aviation world. Have you ever stared at an aviation weather report and felt like you were trying to read alien hieroglyphs? Yeah, we've all been there. Well, today we're clearing up all that mystery. We are going to explain the decoding of METAR and TAF messages step by step. I'm so excited to guide you through this secret language, because once you get it, you'll literally never look at the sky the same way again. So let's jump right in.
Let's be real for a second. Look at this intimidating string of characters. It honestly looks like a cat just walked across a keyboard, doesn't it? DGRN 1900800Z, just a massive jumble of numbers and letters. If you're looking at this and scratching your head, that is totally normal. But the wild part is, for an airline pilot or an air traffic controller, this single line tells a rich, incredibly detailed story about exactly what is happening above an airport. It's quite literally a matter of life or death, absolute safety.
So, to turn this gibberish into a clear roadmap, we're going to use a step-by-step Rosetta Stone approach over the next few minutes. We'll cover the pilot's secret code, the basics of weather vocabulary, decrypting a full METAR, using TAFs to predict the future, and finally, how weather serves safety. Let's get to it.
Section 1, the pilot's secret code. Why do we make things so complicated in the first place?
Well, that brings us right to our starting point, the METAR. It's not just some fancy jargon to make people sound smart. A METAR is a globally standardized aviation weather report. So whether you're landing in Tokyo, New York, or Niamey, the format is exactly the same. It's the absolute pillar of what's known as the Aerodrome Meteorological Watch, or VMA in French. This whole system is a highly strict machine governed by AKIO and the World Meteorological Organization. Their one and only goal? Giving crews real-time observations to guarantee flight safety. Basically, a METAR is just a snapshot of the current weather at a specific airport right at this very second.
Section 2, the basics of weather vocabulary. Before we read a full sentence, we need to learn the building blocks of this new alphabet.
In aviation, we slice up the sky in a very specific way. Picture a pie cut into 8 equal slices. We call these slices octas. These codes tell us exactly how many of those pie slices are filled with clouds. Few means just 1 or 2 octas are covered, so it's pretty clear. SCT stands for scattered, covering 3 to 4 octas. But here's where it gets absolutely crucial. BKN, or broken, which is 5 to 7 octas. Why does this matter? Because BKN is the exact point where we consider there to be a true, solid cloud ceiling, a real visual barrier for the pilot. And finally, OVC for overcast. That's the whole shebang, 8 out of 8 octas completely covered.
Now, the really important thing here is the exception to the rule. Look at this quote straight out of the International Civil Aviation Organization manuals. Cumulonimbus, or CBs, and towering cumulus, TCUs, are always reported. Always. Why the absolute obsession with these clouds? Well, because they are absolute weather monsters. A cumulonimbus is packed with severe thunderstorms, insane turbulence, hail, and heavy icing. I mean, it's literally a pilot's worst nightmare. So it doesn't matter if the rest of the sky is absolutely gorgeous. If there's a CB lurking around, pilots need to know about it instantly.
All right, let's move down to the surface phenomena. This table right here is your cheat sheet for figuring out what's falling from the sky or blocking your view. And luckily, a lot of it is based on English words. For example, R stands for rain, SN is snow, FG is fog, and BR is mist, from the French word brume. Now, to tell you how strong it is, we use prefixes. A minus sign means it's light intensity, and a plus sign means it's heavy. But then there's FZ, which stands for freezing. If you combine FZ with R, you get FCRA. That's freezing rain, which is incredibly dangerous because it causes ice to build up right on the aircraft's wings.
Okay, here's a quick little trap to watch out for. You're going to see this magic number a lot in the visibility section, 9999. Now, if you see this, do not think the visibility is exactly 9,999 meters down to the millimeter. Actually, it's just a universal code telling us that visibility is a very clear 10 kilometers or more. Basically, it's aviation's way of saying, hey, it's super clear out there. You can see for miles.
Section 3, decrypting a full METAR. Step by step. This is the exact moment we've been building up to. We're going to translate that raw code for Neme we saw earlier. Let's pull up that scary message from the beginning and completely tear it apart. Step 1, identification. DRRN is the airport code, in this case Niamey in Niger. Then we have 19800Z. That's your time stamp. It means the 19th day of the month at exactly 0800 UTC, which is what the Z or Zulu stands for. Step 2. The wind. 24015 G28 KT. This means the wind is blowing from a direction of 240 degrees at a steady 15 knots. But watch out for that G. That stands for gusts, and those gusts are kicking up to 28 knots, so expect a bit of a bumpy ride on final approach. Then, step 3, 7,000. That simply tells us the visibility is exactly 7,000 meters.
Let's finish the rest of this sentence. Step 4, the current weather, RABR. Think back to our cheat sheet. The minus sign means light, R is rain, and BR is mist. So we've got light rain and mist. Step 5 is the clouds. Few 10 means a few clouds at 1,000 feet. You just add 2 zeros to that number. SCT 18 is scattered clouds at 1,800 feet, and then BKN 30CB. That's a broken ceiling at 3,000 feet, and look at that, there's our monster, the cumulonimbus, so there are definitely thunderstorms brewing. Finally, step 6, 28/23. That gives us a temperature of 28 degrees Celsius and a dew point of 23 degrees. The fact that those two numbers are so close together actually explains why we have that mist we saw earlier. And Q1010 is just the altimeter setting, or QNH, at 1010 hectopascals. See? It's not gibberish anymore. It's actually a crystal clear picture of what's happening outside.
Now, sometimes Mother Nature gives us a break, and the code gets super short. The absolute best magic word in aviation is CAVOK. That stands for Ceiling and Visibility OK. When you see CAVOK, it completely replaces the visibility, weather, and cloud groups all at once. It literally just means visibility is 10 kilometers or more, there are no clouds below 1,500 meters, absolutely no nasty CBs or TCUs, and no significant weather. Basically, it's aviation's way of telling pilots, hey, it is a gorgeous day, sit back, relax, and don't even sweat it.
Section 4. TAF. Predicting the future. Because knowing what's happening right now is great, but we really need to know what the weather will be like when we actually get there to land. There is a really fundamental difference we need to wrap our heads around here. A METAR is the present reality. It tells us what is happening right this second, and it gets updated every hour or half hour. But a TAF, which stands for Terminal Aerodrome Forecast, is all about the future. It uses the exact same vocabulary structure, but it projects anywhere from 9 up to 30 hours into the future. It's literally the tool pilots use to plan the flight long before they even take off.
To read the future, TAFs use these little time shift indicators. No sig simply means no significant change, so things are going to stay pretty stable. Then you have BECMG, which stands for becoming. This means a permanent change in the weather is going to set in over a specific period. And then there's tempo for temporary. This tells us about a passing phenomenon, something that's going to come and go, lasting less than an hour at a time, like a quick passing rain shower.
So let's apply these new forecasting rules to our Name Airport. Step 1. TAF DRRN 1906/2006. This is a forecast for Name that is valid for 24 hours, from the 19th at 06 to the 20th at 06. Step 2. BECMG 1912/1914 VRB03KT. So between 12 and 14 hours, the wind is permanently becoming variable and very light, just 3 knots. Sounds like a really calm, peaceful afternoon, right? But hold on, look at step 3. Tempo 1918/1921, 4000 TSRA, BKN 010CB. Whoa. Between 18 and 21 hours, expect some serious temporary changes. Visibility is going to drop to 4,000 meters because of thunderstorms, that's the TS, and rain, RA. Plus, we're getting a super low ceiling at 1,000 feet packed with those dangerous cumulonimbus clouds. So yeah, it's going to be a very bumpy, wild evening.
Section 5. Weather at the service of safety. This rigorous system is quite literally the backbone of keeping planes in the air safely. Regular hourly observations are great, but as we all know, weather is incredibly unpredictable. So what happens if a super dense fog suddenly rolls in right in the middle of 2 hourly METARs? Well, that's exactly where a Specy comes in. It's a special observation fired off immediately to warn pilots about a critical deterioration, like a sudden drop in visibility, crazy wind gusts, or a massive wind shift. And on an even bigger scale, we have SIGMENTs. Think of a SIGMENT as the ultimate red alert for dangerous phenomena happening en route. We're talking severe thunderstorms, extreme turbulence, or even something crazy like volcanic ash clouds. This entire alert system is the absolute backbone, guaranteeing that unexpected, dangerous weather instantly reaches the cockpit.
And there we have it. What just looked like a random string of keyboard mashing at the start of this breakdown has transformed into an incredibly clear, vital story about wind, visibility, storms, and the future. You now have the actual key to decoding aviation weather step by step. So the next time you're waiting for a flight or you just see some dark clouds gathering over your local airport, ask yourself, are you ready to read the sky like a pilot? Or is the next storm going to take you by surprise? Thanks so much for joining me on this awesome dive into aviation codes. Keep looking up.